Hey guys, this is Form B of the first benchmark, so hopefully you did the other benchmark practice, and remember that try these problems before watching the explanation video to maximize your practice. Let's get started. Number 1, the function f of x has a slope of -2 and goes to the point -3, 4. For what values of x is f of x negative? I'm just going to plot this and graph it. And we're going to talk about what f of x being negative means in a second. There's my graph. I'm going to plot -3, 4. And if it has a slope of -2, that means every one step to the right, we go down 2. One step to the right, we go down 2. So if we keep that going and draw a straight line through all of that, there is our graph of the function. And it says, well, for what values of x is f of x negative? Well, remember, f of x is our output, or our y value. In other words, we're asking, where is the y value negative? That's the bottom half of that graph, anything down there. So if we look at when does that happen, that happens when the x values from the function are bigger than or equal to -1. If you see from that point on, all the y values are negative. So our answer is going to be C. When f of x is negative, when x is greater than -1. All right, the sequence 27, 24, 21, 18 can be represented by which of the following formulas? A sub n plus a sub n equals a sub 1 plus d times n minus 1. That's the explicit formula. On the other hand, this right here is the recursive formula. A sub n equals d plus a sub n minus 1. There's only one correct answer, so you have to figure out, is the explicit formula correct or is the recursive formula correct? Instead of telling you the answer, I'm just going to tell you what d and a sub 1 are and let you plug in those values and figure out the rest. So notice how our numbers are going down by 3 each time. That means d, the common difference, is -3. A sub 1 is the first term, that is 27. So if you plug those in, you'll notice neither of the recursive formulas are correct, and A is the best answer because that is where D is -3 and A sub 1 is 27. All right, number 3. Juan is preparing to run a marathon. He's figuring how far in feet he is running over time in minutes. Juan modeled his training with the linear function d of t equals 400t, where d of t is the total distance he ran in feet and t is the time in minutes. Which of the following would be a practical range for d of t? Remember that the word range includes all the outputs. So right away I can look at C, and I know that C is only talking about input, so C cannot be correct. Then we want to ask, all right, are negative numbers allowed? If not, then we need to cross one of these out, and the answer would be no, they're not allowed because we're talking about minutes from when he started training, or how far he ran. That crosses out A because d of t is less than or equal to 0 only includes negative numbers and 0. Likewise, what about decimals and fractions? Well, for the output, the range, that's the total distance he ran in feet. Can you run 1.5 feet? Or 3.2 feet? Sure you can. So yes, those are included. So our all whole numbers cannot be correct either because that only includes 1, 2, 3, 4, and so on. So our answer is, our answer is B. That d of t is greater than or equal to 0 is the range of those values of the function. All right. What change could be made to the relation to make it a function? Well, why is it not a function? That's what we need to identify first. Notice this right here, 4 can become either 5 or 8. If we write those as points, those points look like this, 4,5 and 4,8. We need to replace one of those two values so we know that A and D do not work because we're not replacing the correct numbers. If we were to replace it, if we were to replace 4,8 with 4,4, we would still have the problem of 2 4 inputs and different outputs. So that would not work either. Our only answer then, our only leftover option is B. And notice how 4, 5 becomes 3, 5. That means we have different inputs now, and that is perfectly fine. All right. So let me cross that out. We must do B. Number 5, Katie is going to make personalized t-shirts. She starts her business by buying a screen printer for $500. She pays an additional $14 materials for each t-shirt. She's planning on selling the personalized t-shirts for $25 each. Write then solve an inequality to find the number of shirts Katie would have to sell in order to make a profit. Well, in order to make a profit is the key word here. First of all, you have to know how do you make a profit? Well, you've got your expenses and you've got your revenue. A profit is when the revenue, how much money you get, is bigger than the expenses, how much money you use, or the cost. So that is the inequality we need to set up. The expenses are $500 for the printer and $14 for each t-shirt. In other words, 14x plus 500 are the expenses. The revenue, how much money she's making, comes from selling $25 each. So, or for each t-shirt. So 25x will be the revenue. There's our inequality, and notice that there's 2 solutions that work and 2 that don't. A and B do not work because the inequality is pointed the wrong way. Let's solve for x and see what we get. So we're going to subtract 14x from both sides and then divide by 11. And you get this decimal, 45, I'm going to round it, 45.5 is less than x. In other words, she's got to sell at least 45.5 t-shirts. Well, you can't sell half a t-shirt, so the next nearest t-shirt she can sell is 46 t-shirts. So there we have our answer. All right, 46. However, let's see here. Make sure you select the correct one with the correct inequality. Next, the equation C equals 5/9 F minus 32 is used to convert temperature from Fahrenheit to Celsius, where Fahrenheit is the temperature given in degrees Fahrenheit and C is in degrees Celsius. Which of the following is not an equivalent form of the conversion formula? This is tricky because all of these are equal except one. The way I'm going to solve this is I'm going to start with my conversion formula, the one they give us, and I'm going to just start rearranging it and solving it for different variables, and we'll check off each of the equivalent equations. In other words, all the equations that mean the same thing. Okay, so let's start with that. First, I'm going to distribute 5/9 just as an exercise. When you do that, you get 5/9 F minus 160 over 9. Notice that's B right there, so that is an equivalent formula. Check. That is not our answer, because we're looking for which one is not an equivalent formula. Then I'm going to take the same original equation and I'm going to multiply both sides by 9/5. I'm doing that because that will eliminate the fraction and allow the right side to just be F minus 32 when those divide out. Next, I'm going to solve for F because I notice that F is solved for in one of those equations right here. When I solve for F, I add 32 to both sides, and I get 9/5 C plus 32 equals F. That is D. So I have the equation D is one possible correct, or is not a correct answer because it is an equivalent form of the conversion formula. Lastly, I'm going to solve for 32 here, so I'm going to subtract 9/5 C from both sides. Notice I'm just moving these around. And now that 32 is by itself, look, we get one of the other equations. Let me rearrange those. I just switched sides and moved them around a little bit. Negative 9/5 C plus F equals 32. That is C right there. So that is also equivalent. So the only one that is not is A, and that is the correct answer. Number 7. Let f of x be a linear function with y-intercept at 0, 6 containing the point negative 2, 3. The graph g of x is represented below. So we have two different functions here. Watch out for that. F of x is what they described, and g of x is right there below. Which is the correct comparison of the rates of change? Well, if we're comparing rate of change, then we need to calculate that. And remember that rate of change is the same as slope. If I can graph both of these and picture the slope, I can figure out which rate of change is greater. Well, that's g of x. F of x starts at 0, 6, and it has the point -2, 3. With those 2 points, I can see right there, I could draw a straight line, and the slope of this would be going up 3, and then right 2. So rise over run would mean 3 divided by 2. I can use that slope to find the rest of the points, and before I actually figure out the slope of each of them, notice I can make a pretty educated guess out of which one is steeper, in other words, which one has the greater rate of change. It looks like red is a little bit steeper, and so my hunch is that B is the correct answer, that the rate of change of f of x, the red, is greater than the rate of change of g of x, the blue. But let's check and make sure. So, delta y over delta x, in other words, rise over run, for the red is 3 over 2. For the blue, delta y over delta x, we go up 5 every time we go over 4. So 5/4 is the rate of change. Well, which one's bigger? Careful, because if you convert these to decimals, or type that in the calculator, 3 divided by 2, you get 1.5 for the red, f of x, and then for g of x, you get 1.25. By converting it to decimal, it's easy to see that the red is indeed steeper. 1.5 is greater than 1.25, so B is the correct answer there. F of x has a greater rate of change than g of x. All right, number 8. A local animal shelter provides dog walkers with a base salary of $50 per week plus commission. For every dog that they walk, the dog walker will earn an addition, $1 in addition to the base salary. If the base salary triples, how will that affect the graph of the function? Well, in order to see how it affects the graph, we should graph it. Let's start with the base salary. Now, this is a little bit of a trick question because that per week there does not matter. We're looking at it from a whole week perspective. So our equation is 1x plus 50, where x is how many dogs they walk. That x is the number of dogs. If the base salary triples, so we're looking at a new function, well, the base salary was $50, so if we triple that, that's going to be 150. So the other equation is y equals 1x plus 150. They're asking how will that affect the graph of the function. Well, let's graph the blue one first, and I'm going to do a real rough sketch. Let's say that y-intercept is 50. Then the new y-intercept will be 150, and I just made a slope that looks about like 1x. And I know that they both have a slope of 1x, so I know they're actually both parallel here. Well, when I graph both of those, can you guys see what happens when we go from the blue to the red? We're pushing the function up. This is called a vertical translation up. Vertical shrinking and stretching, we'll talk about this in class, but that's stretching it up and down, and you'll see different slope whenever there's a stretch or a shrink. Vertical translation down would be if we moved it or pushed it down, but when you add on to the y-intercept or increase the y-intercept like we did here from 50 to 150, that increasing the y-intercept will move it up, decreasing the y-intercept will move it directly down. All right, number 9. Christina took out an interest-free loan from her parents. She will pay them every month until the loan amount is 0. The current amount she still owes in terms of time in months can be modeled by the function P of m equals 500 minus 330m. What does the coefficient represent in the context of the problem? First thing you need to know is your vocabulary. What does the word coefficient mean? A coefficient is any number that's multiplied by a variable. So the number that is multiplied by a variable. Right here, the coefficient is being multiplied by m, that is negative 30. So negative 30 is the number that they're asking for. What does the coefficient represent? In other words, what does the negative 30 represent? That's not the initial amount of the loan. It's not the current amount of loan. It's not the number of payments she's made. That minus 30, if m is the number of months, minus 30 is how much she pays each month, the monthly payment amount. All right, number 10. Before you go any further, I want you to pause the video and try plugging this into your calculator without me reminding you of all the buttons first. All right, did you pause it and try the problem? Here's what you're going to press. You're going to press stat, then edit. Then you're going to type that into L1 and L2. This is our scatter plot and finding the linear regression of the scatter plot. Next, you're going to click stat and then go overwrite to calc. And then you're going to go down to the fourth one, Linreg, linear regression. And when you do that, you get this equation. That is, you get that equation when it's rounded. Now, there are two answers here, A and C. And we need to figure out which of these is correct. The second part of the question is asking, using the model, determine the time in seconds it would take for a student to complete the sprint after having trained for 7 weeks. Well, be careful because 7 weeks, this is not put in weeks, this is put in terms of days. So we need to convert 7 weeks to days. 7 times 7 is 49, so that is 7 weeks is 49 days. That is our x value, so we're going to plug in 49 there, and when you do that, then you get 13.81, which is C. Watch out for units like that. Alright, next, solve the equation below for T. Grid in your answer. We're going to solve for T. I'm going to distribute the negative there. Make sure that negative goes to both the 7 and the negative 3t, so negative times a negative is positive 3t. And once you do that, the rest of this is fairly routine. Combine like terms, subtract the variable from one side, get the variable by itself, and you get t equals 6. Now, one comment about these grids. Notice this grid does not have any negative. That means if you get to a grid that does not have a negative and your answer is negative, then you're wrong. You need to go back and redo the problem and check your work. Okay? I'm going to plug in 6 there and grid that in, and that is just great. Let's do number 12. If h of x equals negative x squared minus 2x plus 8, find h of 3 halves. Before you panic, here's what I want you to do. You see this, how I plugged in 3 halves in for x? Everywhere I saw an x, I plugged in 3 halves. You can type this in the calculator. In fact, go ahead and practice typing that into your calculator. In parentheses, you can put 3 divided by 2 if you don't have the fraction button like some calculators do. When you type that in, you should get 2.75. Pretty straightforward, huh? All right. So 2.75, notice the decimal takes up a spot in these grids. So 2.75 looks something like that. All right, next up, given the following functions, f of x and g of x, complete each of the statements below. G of 2 means you plug in 2, and the output is whatever the y value is at that point on G. In this case, the output is 4. For B, this is actually a tricky problem. I don't like this because it gives you one output, but there are actually 2 possible inputs. There's that one, that point over there, which is on f of x, and there's that one. So I'm going to write down that there's a second correct answer. X equals 5 gives us an output of 1, but x equals negative 3 also gives us an output of 1. So go ahead and write down both of those as correct answers, and I'll make sure on the test there's either only 1 or there's 2 blanks. Alright, C. Given the following interval, negative infinity is less than x, which is less than or equal to 1, f of x is what? Well, the interval is decreasing because it's that point right there, that side that they're talking about, everything less than or equal to 1. The interval is decreasing. The graph is decreasing there. Likewise, as x is increasing, g of x is always increasing. So as you go to the right, g of x is always getting bigger. Increasing. The domain of g of x is everything greater than or equal to negative 2, because domain is all the x values. Now the way we write that is bracket negative 2, comma, infinity with a parentheses. Also, the range of f of x, that's how far up and down it goes, it seems to be going up infinitely because it's the absolute value function. So we have bracket negative 3, comma, infinity in parentheses. All right. Last question. Nope, second last. The Millers and Jones families are going on a cross-country trip. The Millers leave 50 miles behind the Jones families but travel at a rate of 60 miles per hour. The Jones trip can be modeled by the graph given below. Are the functions modeled by the two families' trips linear? Justify your answer. Yes, because they both have a constant rate of change. It can be seen on the graph that makes a straight line and why it's a constant rate of change. On the other, for the verbal function, they say they're traveling at a rate of 60 miles per hour. So if they're always going at 60 miles per hour, they're going at a constant rate. Part B. Identify the slopes of both functions. That 60 miles per hour is the rate of change. That's the slope. But for the graph, we're going to have to calculate slope by doing rise over run. So rise, 110 over run, 2, that's delta y over delta x, is 110 over 2, which is 55. So the Millers go 60 miles per hour, while the Jones go 55 miles per hour. That is their speed. The rate of change represents how fast they're going, and that's measured in miles per hour. Identify the x and y intercepts of the Jones function. What does each intercept mean in the context of the problem? Well, just the Jones we see right there is 0, 0. So the x and y intercepts are 0, 0 for the Jones family. This means that they started, that's x equals 0, at distance equals 0. Started at the starting point, y equals 0. Lastly, the Millers and Jones want to meet up for dinner. How many miles into the trip will they be when they meet up? And justify your answer. Well, I know that the equation for the Jones is 55x because I've calculated that was the slope. And their y-intercept was 0, so y equals 55x is their equation. The Millers, on the other hand, well, let's see, they are going 60 miles per hour, so 60x minus 50, because it says they leave 50 miles behind. So they are minus 50. Now, something I know about this is that if they're going to meet up in the trip, that means their distance, their y, needs to be equal. How far they are, where they are in location. So, if their distance needs to be equal, the y values need to be equal. So if they have the same y values, let's make 55 equal to 60x minus 50. That's going to set their y values to be the same. Now we have an equation that we can solve over here on the right, and we'll find out what x makes the two sides equal. Anytime you have an equation or two equations and they're meeting, you can just say, hey, if they're both equal to y, what if they're equal to each other, and solve it. So let's solve for x here. I'm going to subtract 55x from both sides just to get them all on one side. 0, don't forget that, 0 equals 5x minus 50. Now I'm going to add 50 to both sides and start getting the stuff away from the x. We get 50 equals 5x, divide by 5, and you get x. In other words, the number of miles into the trip is 10. Whoops. Sorry, that is not miles. That's how many hours into the trip. To calculate how many miles into the trip, you'll then plug that in to the original equation. Like so. So you can actually plug it into either equation. I'm going to plug it into the easier equation, the one that has less stuff with it. So the Jones equation, y equals 55x. Let's plug in 10 for x. You get 55 times 10, which is 550. So they will meet up 550 miles, or 10 hours, into their trip. All right, last problem here. Jack is analyzing the cost of going to an online college versus a traditional college. He realized that the online college is getting cheaper and that the traditional college is getting more expensive. Let x represent the number of years in time since 2000 and y represent the total cost of schooling in thousands of dollars. The cost for attending a traditional college can be modeled by t of x. The cost for attending an online college can be modeled by c of x. So let's color code this. First, I'm going to make a table from the traditional college, T. X is years and T is the cost of the school. So we plug in 0 years, that's going to give us 3.8. If we plug in 1 year into that, we're going to get 4. Plug in 2, you get 4.2, and 3, you get 4.4. This will help us graph it in a moment. Let's now make a table for C of X. Here's X and C of X. Remember, X is years and C is the cost of the school online. At 0, we have 7.5. 1, we have 7.1. 2 is 6.7. And 3 is 6.3. So, one last thing I'm going to do is I'm going to go ahead and skip a few and go all the way to x equals 10, because that's going to help me graph it more accurately. So when you plug in 10 into the blue equation, T of X, you get 5.8. When you plug in 10 into the red equation, you get 3.5, and you'll see why we do that in a moment. All right, let's plot the points. 0, 3.8, 1, 4, 1, 2, 4.2, and 3, 4.4. Notice how these are all really close together, and I could try to draw a straight line, but I might get anywhere from that to that and anywhere in between. I'm not really sure what my straight line should look like. So that's why I found the 10th, when x equals 10, that point, and now I have a better guiding line for when I want to draw a straight line. Let's go ahead and make the red dots, and I did the same thing for that 10, 3.5. Be very careful with how you plot those points. And those are our two lines, T of X and C of X. Notice it also says make sure to label the axes. So on X, we need to say years since 2000. So I know if I look at the 12 there, that's the years, that would be 2012, because that's 12 years since 2000. The Y value is the cost of college, and that's in thousands of dollars. So don't be fooled, that's not $8, that's $8,000. All right. Now, in what year did the cost of attending online college become cheaper than the cost of attending a traditional college? Well, it looks like it happened somewhere around here. You see where those cross and meet? And then they switch which one's bigger? Well, that looks like it's about the 6. So I'm going to put about 2006, since that's what the 6 means. But however, we can calculate this exactly by setting the two sides equal to each other. When was it that they were equal, and when did that switch occur? Well, just like we mentioned before, if the y values are equal, the cost is equal, then those two sides of the equation must be equal. So let's solve for x. Add 0.4x to both sides, then subtract 3.8 from both sides, divide by 0.6, and you get x equals 6.17. That's great, because that was really close to our approximation. If x is 6.17, that means that many years after 2000, we actually were in the year 2006. Great. All right. Would the model for the cost of attending an online college be appropriate to use in the year 2020? Well, first of all, that would be when x is equal to 20. So look at the graph real quick, and the online college is the red one. You guys see how it looks like that red line goes down below? It looks like it goes down below the x-axis down over there at 20. Let's plug in 20 and see what happens. So C of 20 equals negative 0.4 times 20 plus 7.5. When you plug that in, you get negative 0.5. Is that reasonable? Well, no, they're not going to pay you to go to college. So once it becomes a negative number, it is not reasonable. No, because it's negative. You can see that on the graph up there by the line if it kept going on down. Now, what are appropriate domain and range for each of the functions? The domain for the blue one, for t of x, starts at 0 on the x and goes all the way to infinity. So we want to have a bracket around the 0 to show we include 0, and a parentheses around the infinity. The range, likewise, is 3.8 and up. So bracket 3.8, comma, infinity. Because the cost of the traditional school, the t of x, keeps going up and up and up. Online school is a little different. We have 0 to infinity again for the range, and for the domain, the range, the highest it goes is 7.5. So we want to say everything less than 7.5. The way you say that with interval notation is negative infinity, comma, 7.5 with a closed bracket. Now that would work fine if this was just an equation, but we're in a situation, and we just said that we can't really have negative values for the cost of college. So I'm going to put that in parentheses there, and I'm going to give an even better answer. Notice how that line, if I extend the red line, seems to go to x equals 19. I'm just going to say it goes to 19. We could actually calculate it and figure it out exactly, but let's just say it goes to 19 so that we have some bearing to go off of. Then the years since 2000 will only go up to 19, because if they go past that, we're in the negatives. So 0 all the way up to 19. Likewise, the range for the function, the lowest it goes is 0, and the highest it goes is 7.5. So we want to have 0 to 7.5 and have brackets to indicate that we're including both of those as well. That is indeed the better answer between the two of them. And I hope you understand why, is because in the context, we can't have negative y values for either function, but the red one is the only one it really comes into play with. All right, thank you for watching.